Okay, and last of all, question 4. So, can we see that? Yeah, right. We need an equation for the reaction of chlorine with cold water. I'm not going to write this because, I mean, it is what it is. You just need to know it, basically. But even if you, well, you need to know that you're going to get HClO. And if you know you get that, then you can work out, even if you can't remember, that you're going to get HCl. Yeah, this question is pretty straightforward, just looking at the mark scheme. So I'm going to move on to question C. Bromine reacts with phosphorus to form phosphorus tribromide, so PBr3. Write an equation for this reaction and draw the shape of the phosphorus tribromide. It doesn't actually ask for the shape, but it does ask you to suggest the bond angle. So first of all, the equation then. So you should, well, we've got bromine, so obviously bromine doesn't ask for state symbols, is Br2. And then what this comes down to really is that you know that the formula of phosphorus is P4. And if you got this wrong, that is probably where you went wrong. So then you're going to get PBr3, and then it's just a case of balancing that. So if we say 4 PBr3, and then we can balance our bromines over here with a 6. Now, in terms of the shape, if we look at our periodic table, we can see that phosphorus is in group 5, but it's only got 3 things, specifically bromines around it. Okay, which means if it's in group 5 and it's got 3 bonding pairs, it's going to be left with a lone pair. Okay, and you might, because you know, I said to you before, you learn specific examples, but you'll be asked about, and more than likely you're going to be asked about an unknown compound. They're never going to say, you know, what's the shape of ammonia, because it's a standard one that you learn. But actually, if you look, nitrogen is also in group 5, and nitrogen has 3 hydrogens around it, leaving it with a lone pair. So if you have memorised the shape of ammonia, then you can just apply that here, because you've got a group 5 thing with 3 things around it. So we're going to have, what have we got? Phosphorus, and then we've got a lone pair, and we've got our bromines. And this is based on a tetrahedral shape, because we've got 4 areas of electron density here, which would mean that you had bond angles of 109.5 degrees. With the presence of a lone pair, it's going to reduce that bond angle, so it would be reasonable to suggest a bond angle of 107 degrees. However, they accept, I think, quite a wide range here, because actually, for reasons you don't need to worry about, the bond angles between the bonds here are 101, and that's why there's quite a wide range in the mark scheme. Is that all they want? Yep, that's it. Okay, next question. Phosphorus pentabromide in the solid state consists of PBr4 plus and Br minus ions. It wants the shape and suggestion for the bond angle. Again, you don't need to name the shape. This is trigonal pyramidal, but you don't need to name it. So what I'm going to do for this one then, we've got P, so this is kind of the long-winded way, I suppose, but I would recommend sticking to it if you find these difficult, because it's fairly foolproof. So phosphorus is in group 5. So group 5, it has got, where are we, 4. So bonding pairs, it's got 4, and a plus sign means it's lost an electron, so -1 electron. So then we've got 5 plus 4 minus 1 equals 8. Okay, so this works if you can do it whether it's ionic or not. If you've got a plus, that means it's lost an electron, so you're going to take one away. If there was a negative charge there, it's gained an electron, so you would add one. So you say the group, and then however many bonding pair electrons, you add that to it. However many non-bonding pair electrons, you add that to it. Then you've got this number here, and you divide that by 2, so that's the total number of electrons. Divide that by 2 equals obviously 4 areas of electron density. 4 areas of electron density equals tetrahedral. Okay, with a bond angle or bond angles of 109.5 degrees. And if we draw that, we're going to have P, BR, 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 BR. And I'm just going to shove some brackets around that and put a plus there. Now actually my diagram here is a little bit on the dodgy side. I'll probably just about get away with it. I'm going to do a bit more of an angle there. You need to make sure in a tetrahedral diagram that there are no straight lines through anywhere. So like here, okay, and that's just about in case it's going off to an angle. Here, that's okay. There's nothing on the diagonal. You can't have anything directly opposite one another, okay? You don't need to do wedges and dashes, but you can do if you want, as long as you get it right. But yeah, just regular bonds is fine. Okay, I think that's it, isn't it? Yep.